Hello again. Sensor fusion and ADAS perception algorithms are more like left hand and right hand, they go hand in hand. That's the reason I decided to include this ADAS perception algorithm into the same module. Let me clearly explain to you what are the various ADAS perception algorithm applications and what are the names of many of the ready-made algorithms that are available in the market. Now, as you all know, well, let me take a pointer. As you all know, advanced driver assistance systems rely heavily on the perception algorithms to interpret the environment around the vehicle. Okay, so these algorithms are the actual, how to say, tools that process the data from sensors, from cameras, radar, lidar and ultrasonic sensors to detect, classify and track objects. Below is a detailed breakdown of the key perception algorithms in the ADAS functions. Now understand this, many perception algorithms are already available in the market for some preset applications. Okay, the first and foremost application is object detection algorithm, an algorithm which is required to detect a object. Now object detection identifies and localizes objects in the sensor data, whether they are vehicles or pedestrians or traffic signs. Understand this word very carefully, detection. Okay, now when it comes to camera based detection, there are many traditional methods like Haar cascades or HOG, histogram of oriented gradients used for pedestrian detection. And next most important camera based detection algorithm is SIFT or SURF, which is an acronym for scale invariant feature transform or speeded up robust features. Feature based detection, which is less common now. Actually this is less common now according to few people. Next comes the most important, deep learning based methods. Now these are the methods through which the detection is happening. One is YOLO. YOLO is a very popular algorithm. You look only once. YOLO stands for you look only once, for the fast real-time detection with single neural network pass. Okay. Next comes the faster RCNN. RCNN stands for convolutional neural network. Now, region-based CNN for high accuracy, but it is slower than YOLO. YOLO is the most popular network or algorithm because of its rapid detection capability. Next comes the SSD, single shot multi-box detector, balances speed and accuracy. Next comes Retina Net. Okay, this is actually a very how to say, a very less popular one, but still I will mention it here because it handles the class imbalance with focal loss. Now we touched upon the traditional method, we touched upon the touched upon the deep learning. Next comes the radar based detection. When it comes to radar based detection, the CFAR, constant false alarm rate, is the most popular algorithm. Now detects the objects in radar signals while filtering the noise. Noise is nothing but collision of the radar signals with other signals. It may be a light signal or it may be ultrasonic signal. So it clearly obliterates or eradicates or filters out the other signals. Next comes the DB scan, density based spatial clustering. So clusters radar points into objects, and this is exactly how it is only through clustering the radar points into objects that object can be detected and also identified to some extent. It is not exactly when it comes to identification, radar plays a very minimum role, but it definitely helps in a little bit of identification because it clusters all the points into a given object. And when it comes to lidar based detection, there is something called point cloud processing, and within point cloud processing there are some methods like voxel based methods, point net plus, and also second, the acronym is second, it is sparsely embedded convolutional detection. Efficient lidar object detection. So always understand this. So there is camera based detection, there is lidar based detection and lidar based detection, and all these three are serving the same application, which is object detection algorithms. Next comes the semantic segmentation. Okay, what is semantic segmentation? In simple words, it assigns a class label to every pixel in the image. Every image has number of pixels and to what class it belongs to. that is labeled in semantic segmentation. Okay, so with the help of this semantic segmentation, you clearly identified whether it is a road or a car or a pedestrian. Now, when it comes to fully semantic segmentation, this FSN fully convolutional network is the most popular network or most popular algorithm because it is very early deep learning method. Next comes the UNet, popular for medical imaging but used in ADAS for precise segmentation. When it comes to DeepLab V3, it uses Atro's convolution for better feature extractions. See, I request all of you to don't worry about or don't get intimidated by these very hi-fi words like Atro's convolution or deep learning approach. These are all the various types of how to say deep learning or identification process which are used in these algorithms. You don't need to worry about these things unless you are the research person who's developing an algorithm, because most of the algorithms are off the shelf. You won't need to learn very deeply about these things. Next important semantic segmentation is PSPNet, or acronym for Pyramid Scene Parsing Network. Okay, it captures the multi-scale context. Next comes the instance segmentation. Now, this instance segmentation is very popular as far as this perception is concerned. Detects objects at pixel level while distinguishing between different instances. For example, between two cars. And how does it do that? Detect objects at pixel level. By detecting the objects at pixel level, it detects the two cars. For example, you are traveling on the road, and in front of you there is one Toyota car and there is another Ford car. It clearly distinguishes between the two cars with the help of instant segmentation. And how does it do? What is the name of the algorithms? First is mask or CNN, second is solo. Mark or CNN extends faster or CNN with segmentation branch, and solo it directly predicts the instant mask. That is the reason solo is more popular than mask or CNN. Alright, next comes the object tracking. First we check the object detection, now comes the object tracking. Object tracking maintains the identity of the detected objects across the frames. So as the detected object is moving across the frame, for example from left to side, it keeps a track that the same object on the left is the same one on the right. Okay, for example, when the vehicle is going on the road, a vehicle cuts in front of you from left to right. Okay, then it clearly keeps an idea that it is the same car which was on the left side on the road which came to the right side of the road. So this is what is meant by object tracking. And what are the various methodologies? First is Kalman filter. This Kalman filter is a very popular sensor fusion methodology, and it predicts the object motion based on past observations. Next is particular filter, handles non-linear motion, pedestrians changing direction. Now usually most of the time Kalman filter is capable of handling what particular filter is there, but some OEMs, if at all there is any cons constraint, they may use the particle filter also. Next comes the deep learning trackers, and within this deep learning trackers there are plenty of off-the-shelf algorithms like sort, simple online and real-time tracking, deep sort, Fairmont. These are all the various brands or the various types of the tracking algorithms. Now comes the most important algorithm, which is sensor fusion. Now I very clearly explained to you what is meant by sensor fusion, so I'll slightly breeze past this topics which I mentioned here. First is early fusion. Well, you fully know what is meant by early fusion. It combines the raw sensor data before processing. Late fusion means it first processes and then combines. Next is deep learning based fusion, MV3D, multi-view 3D object detection. It fuses LiDAR and camera data and aggregate view object detection. It improves 3D detection accuracy. Next comes the lane detection and road understanding. It identifies the lane markings and the road boundaries. Traditional methods like how transform, ransack. Ransack is the acronym for random sample consensus, and it fits the lane models very robustly. This is a very robust model for lane detection. Next comes deep learning methods. When it comes to deep learning methods, LaneNet and PolyLaneNet, these are a very popular algorithms The lane net uses a neural network, and polylane net it predicts lane polynomials directly. Lane polynomial is nothing but the equation of the curvature of the road which is lying in front of you. I am sure everybody who has done some basic mathematics know that every curve has its own linear or polynomial, or it may be quadratic or a cubic equation. So every line has its own polynomial, and it predicts the polynomial equation in a very concise, precise manner. Now, what are the further applications? The further applications are traffic sign and traffic light recognition. Even they have this particular algorithm also has, or this particular functionality has its own ready-made perception algorithms. For example, CNN based classification like LaneNet 5, AlexNet used for sign recognition, and traffic sign recognition often use YOLO and faster or CNN. Well, I'm sure you know what is YOLO. You only look once. Next is the free space detection. Now, this is very important when it comes to urban driving and also for autonomous parking. Most of the vehicles, even in India, are using this. For example, Skoda Rapid or Skoda Slavia or Volkswagen Virtus, they are already using this free space detection. And how do they do it? By occupancy grid mapping. It uses LiDAR or radar to mark free versus occupied space. Alright, when it comes to stick cell world model represents the environment as vertical sticks. Okay, just like pixel, there is also stick cell. Now here I will give you a small task. Go to internet and check what is meant by stick cell. It's a very interesting topic. I am sure you will enjoy learning about it. Last but not the least comes the depth estimation. What is meant by depth estimation, and how is depth estimated? With the help of monocular or stereo vision. It estimates the distance to the objects using cameras. Stereo vision, like a semi-global matching, it computes disparity maps. And molecular depth estimation, products depth from single image. Next comes MIDAS, general purpose depth estimation. Okay, this MIDAS is a very state-of-art multi-scale deep network, or a very modern algorithm which is used for estimating the depth. Last but not the least, or the most important one, is SLAM, which is acronym for simultaneous localization and mapping. It is used for autonomous parking and low speed maneuvers. Okay, understand this very carefully. It is used for autonomous parking and low speed maneuvers. And what are the various types of SLAM algorithms? It may be visual SLAM, which uses the camera data, or the LiDAR SLAM, which is more accurate for 3D mapping. Alright, so all these 10 types of applications in which there are plenty of off-the-shelf perception algorithms in the market. This is what I wanted to cover and extensively covered. Alright, so in conclusion, let me point out that ADAS perception algorithms vary based on sensor inputs and application requirement. Now, this is not a exhaustive list, mind you. As I am speaking, some research is going on, and I am 100% sure some new algorithms are coming into the market every day. New algorithms, new perception technologies which are more accurate, which have more less latency, which are more real-time operating conditions. They are coming into market day by day. Now, deep learning especially dominates the modern systems, but traditional computer vision and sensor fusion, they remain crucial for robustness. For robustness and ruggedness, even today, traditional computer vision is required. Now, future advancements will focus on multimodal fusion, real-time efficiency, and edge AI deployment. Now, these are the how to say future advancements or the future trends. All right. Thank you.